Hey everyone, welcome back to Fundamentally Clear, the series where we simplify design patterns one day at a time. I'm your host, and today we're on day 8, the Decorator Design Pattern. But before we dive in, let me paint a picture that every developer has faced at some point. Imagine you're building a coffee ordering system. You start with a simple coffee class. Easy enough. But then your product manager says, we need milk coffee, sugar coffee, cream coffee, and also milk sugar coffee, sugar cream coffee, and milk sugar cream coffee. Suddenly, you're staring at an explosion of subclasses. Every new combination means a brand new class. Your codebase becomes a nightmare to maintain, impossible to scale, and painful to extend. This is what we call class explosion, and it's a very real problem when you try to add features through inheritance alone. So the question is, how do we add new behaviors to objects without creating a new class for every single combination? That's exactly where the Decorator Design Pattern comes in. The Decorator pattern lets you wrap an existing object and add new behavior on top of it, without touching the original class at all. Think of it like decorating a Christmas tree. You start with a plain tree. Then you add a star, some ornaments, some lights. Each addition enhances the tree, but the tree itself never changed. In code terms, Decorator uses composition instead of inheritance. You stack behaviors dynamically, and you can combine them in any order you want. It's clean, flexible, and fully respects the open/closed principle. Open for extension, closed for modification. Let's see how this looks in C# using our coffee example. Step 1. We define the base contract, an iCoffee interface with two methods, getDescription and getCost. This is the common type that both the real object and all decorators will implement. Step 2. We create the concrete base object. Simple Coffee implements iCoffee, returns the description Simple Coffee, and a base cost of 5.0. This is your starting point, your plain tree. Step 3. We create the base decorator. Coffee Decorator is an abstract class that also implements iCoffee, but internally it holds a reference to another iCoffee object. It delegates calls to that wrapped object. This is the magic glue. The decorator is a coffee, and it has a coffee. Step 4. Now we build concrete decorators. Milk Detector extends Coffee Decorator. It appends quote, comma, milk quote to the description and adds 2.0 to the cost. Sugar Decorator does the same. Appends quote, comma, sugar quote and adds 1.0. Each decorator wraps the previous object and layers its own behavior on top. You can stack them in any order, any combination at runtime. Now, if you're preparing for interviews, here are the 5 questions you absolutely must be ready for on this pattern. What problem does the decorator pattern solve? Class explosion from inheritance. What's the difference between decorator and inheritance? Decorator uses composition and is dynamic. Inheritance is static and compile time. When should you use decorator? When you need to add responsibilities to objects without modifying existing code. Can decorators be combined? Yes, that's the whole point. Stack as many as you need. Real-world examples? Stream classes in .NET, middleware pipelines in ASP.NET Core, and logging wrappers are all classic examples. So here's the takeaway. Decorator allows you to add behavior to objects without modifying their code, making your systems flexible and scalable. It avoids class explosion, promotes composition over inheritance, and supports truly dynamic behavior. Remember this formula. Decorator equals wrap plus extend behavior. That's a wrap on day 8. Coming up next is the facade design pattern, where we learn how to simplify complex subsystems behind a clean, unified interface. You don't want to miss it. If this helped you, like and share it, and follow at Fundamentally Clear for more. Keep following the series to master all 23 design patterns with practical C# examples. See you in the next one.